At 35,000 feet, you're sitting in a pressurized cabin, sipping a drink, watching a movie, and charging your phone. Outside the aircraft, the air is too thin to breathe. Temperatures are colder than 60 degrees, and there's no infrastructure in sight. Yet inside, everything just works. How? The secret is electronics. Not just wires and switches, but a complex, multi-redundant electrical ecosystem powering every function on board, from engine sensors to touchscreen displays. Unlike cars, airplanes don't rely on big batteries. Instead, most of the electricity is generated mid-flight by generators attached to the engines. As the turbines spin, they drive integrated generators that produce 115 volts of AC power at 400 Hz, more efficient than your home current, and optimized for aviation-grade equipment. Each engine powers its own generator. If one fails, the other can handle the load. But there's a backup for that too, the APU, or Auxiliary Power Unit, a smaller turbine in the tail that provides electricity when engines are off or unavailable. And beyond that, high-capacity batteries designed for emergencies. And even beyond that, the Ram Air Turbine, a fold-out propeller that uses airspeed to generate power if everything else stops working. Yes, airplanes can generate their own electricity, even with both engines out. All that energy is routed through miles of aircraft wiring. For example, the Boeing 787 has over 60 miles of cable. These wires are protected against heat, pressure changes, vibration, and electromagnetic interference. Systems are divided: flight control, navigation, cabin lights, entertainment, each isolated so no single failure spreads chaos. But power generation is just one piece. How that power is used is even more fascinating. Modern jets are controlled by fly-by-wire. When a pilot moves the controls, it doesn't push a mechanical rod. It sends a digital signal to computers. Those computers decide exactly how to move flaps, rudders, and elevators faster, more precisely, and more safely than any human could alone. Every command is verified, cross-checked, and backed by at least 2 or 3 redundant processors. Meanwhile, thousands of sensors monitor everything from cabin pressure and wing stress to fuel temperature and weather data. They feed real-time information to dozens of subsystems, adjusting climate, controlling engine performance, and alerting crew if anything deviates from expected values. Entertainment systems, totally separate. The video screen in your seat draws from a different circuit than the one controlling the engines. A Boeing 777 in flight can generate over 1 megawatt of electricity, enough to power 300 homes. And all of that is managed silently, continuously, without you ever noticing. Airplanes are also incredibly secure. Critical flight systems are physically and digitally separated from passenger systems. Even Wi-Fi is firewalled from flight control. And all components are built to run for tens of thousands of hours without crashing or restarting. It's not just a flying vehicle. It's a self-contained, intelligent, responsive, and resilient power grid that happens to travel at 550 miles per hour. Next time you plug in your phone or tap the screen at your seat, remember, it's all powered by a high-speed ballet of turbines, processors, relays, and diagnostics working non-stop, just so you can fly safely through the sky. Thanks for watching Almost Fiction. If you thought airplanes were just about wings and engines, now you know. It's also about invisible systems keeping you safe every second. Every week, we dive into stories that seem unbelievable, but they're real, verified, and happening right above your head. If you enjoyed this breakdown, hit subscribe and turn on notifications. And if you've got a topic you want us to uncover next, drop it in the comments. Because the closer you look at the real world, the more fiction it starts to sound like. And we're here to explain every bit of it.